Hello, hello, hello. Hello, welcome along. It's good to be back and all that kind of stuff. I have my spare room back now, so I can get back to the streaming. How are people? Hope you're well. And yes, welcome along. Like I was saying the last time, I have the last week or so I haven't been able to do any streams or anything like that. I haven't really been able to do much at all, Amiga wise. So gonna make up for that now. Going to start with yes. So just the one thing that I wanted to cover the last time I completely forgot about was collision detection between sprites and something else. Basically between sprites and sprites, and between sprites and playfield, and the two different sort of built-in ways of doing collision detection. Like for games, you can always do your own sort of manual collision detection with with what you'd call hitboxes and stuff like that, and do a sort of mathematical calculation based on the positions, and have a map that so you can decide whether your player is in or out of an area, or is touching an object, or whatever. You can do that kind of in code, but there is hardware support for a certain amount of collision detection with the sprites, with the Amiga sprites. And so if that's all you need, then sometimes that's enough, especially if the sprite is just going to be like a bullet or something like that. It's or a boundary areas. It can be useful, and just it's there. It's limited, but it does work. And I'm gonna give that a go now, because we didn't cover it the last time. So here's what we have. But I also won't be having beers. I would normally have a couple of beers on a weekend stream, but I had a lot of beers last night, so I won't be doing that again for a while. But yes, anyway, here we are. What I'll do is we'll look at it in the Amiga Blitz editor, because that's just a bit nicer. And sorry, it's not the full frame. Yeah, I can't remember exactly what. Oh yeah, because I can't do overscan because I switched to RTG. So the window's a slightly funky size. It'll be fine. Okay, so this is our code, and what we're doing is we're setting up basically 4 balls, and what we're going to do is we're just going to bounce them around the screen and show you what basically create these sprites. Oh, sorry, we're only doing 3 of them actually, and show you, basically show you when they collide and when they collide with graphics on the screen. So so what you have is, well, we're setting we're just setting up our palette, but so we've got black and white colors, and then we've got like basically random colors for the rest of them. And so this is actually a pretty cool trick for drawing shapes directly. So what we're doing here is we create a blank shape, and we give it an ID, and we give it a set of dimensions. Image. What is that doing? I have no idea why the help is not working for that. That's strange. Anyways, so we give it a shape ID, and we give it dimensions, 32 by 32 by 2 bit planes, which is a 4-color shape. And what we can do then is we use the shapes bitmap command to set the shape object 0 to bitmap 1. And once we do that, we can draw directly onto the shape with the normal drawing commands. So we're drawing 3 circles basically, and all we're doing is we draw our circle, and we're doing 15 by 15 and 15 radius, and we're filling it in color 1, 2, or 3, and then we're just going to get get 3 separate sprite objects coming from those. And that's basically it. We're just setting some coordinates and some random speeds on there, and it'll just basically bounce them around the screen. So what we have here is we're going to draw boxes. Basically, this is just draw a border around the edge of the screen, around the edge of the main bitmap, and a bunch of lines on it. So what we're doing then is, this is the set call command. Now that is annoying the way it won't, help won't work there. So I'm going to quit this and try again. When in doubt, switch it off and on again. So let me see, that was... tutorial 10, wasn't it? Yeah. So let's see if it works now. Box. Yeah. Yeah. Okay. So that's all fine. So what we're doing is, yeah, we're setting up our display here and set call. Now, this is the interesting bit. Okay. So what you have to do is you set up what type of collisions you want, and with your sprites, and basically then you sort of you check to see if a collision has happened, and that's you do that basically, you know, every time in your game loop. So that's all this is doing. But set call basically sets what type of collision you want. So you can see here that you can do, you choose color and bit planes. And yeah, so basically that will that sets up that yeah, so color, yeah, so whenever it will return true whenever you get a collision with that particular color. Okay. Bit planes, you can use that to limit how many bit planes are actually checked, and that just kind of like, you know, that means you can do things like have certain colors that are only use other bit planes, and they'll be completely ignored, you see, so you don't get a collision with these colors. And yeah, so that's basically it. And then we could just get our main loop here, and you can see here's the key thing here: do collision, do call. That what actually does the calculations and checks to see if the sprite is colliding with any of your graphics. And then basically pcall is the function that gives you a playfield collision, you see. So it gives you a true if you get a if you get a collision. So that's it. Basically it just checks your particular sprite channel, and that's all it does. That's all you give it. So you say, yes, sprite channel is I-1 times 2. Yeah, it's slightly awkward, but yeah, so you know, if you're displaying your sprite in channel 0, you use channel 0 for that. And basically what's happening there is, yeah, that will return true if you've got a playfield collision that sort of with that particular sprite channel. And then you've got scall, and that is sprite collision, and so that checks, that takes 2 sprite channels instead of 1, and that will check if they are colliding with each other. Now these are sort of, you know, graphical collisions, as in, you know, they're where the actual pixels overlap, and so, you know, they take into account the shape of the graphics. By the way, let me know if the audio is a bit funky or if it's kind of the right levels. I have, you know, just a little bit of background music there, a couple of mods playing. But yeah, so what we're doing is we do basically what we're doing is we're checking if we get collisions between all 3 sprites. So we're displaying sprites on channels 0, 2 and 4, and we're checking all 3 combinations of them to see if any 2 sprites are colliding. And what we do in each case is we set the palette to a different color. So that's grey, that's red, that's green, and that's blue. And then we set this flash flag to true. So what happens is at the end we say if there are no collisions happening, then flash will be false, and we set the background to 0. So color rate is 0. So we set it to black again, and then each loop we just activate that particular palette. All right. So let's give this a go. I'm going to actually compile it in Blitz 2 just because of issues we've had. But that's the exact same code. There's our collision code down there. Let's see if it works. Make smallest. Okay. Now, it does jump a little bit there. That's a WinUAE thing. Don't worry, that won't happen on real hardware. But you can see there's the 3 balls bouncing around, and when they hit each other, you get a particular color. When you get when they hit certain pens in the background, you get a particular color as well. So what I can do is I can disable it and just show you the particular one particular color, if you like. So let's see what we have. So what we'll do is we'll just comment out the sprite collisions for now. So it'll only flash when we get a collision with the colors, with the on-screen colors. Ugh, that's jumping a lot. But yeah, so that's basically when any of the sprites are touching color, whatever it was that we picked. Was it color 1? Yeah. So set call there. So let's have a look at the information on that. So single color. So yeah, we just choose color 1. I think it was, wasn't it? Set collision 1, and we are doing a 4-bit plane check, but you don't really need to do that. It depends on like I said, it depends on what your color is, and just how exactly you want to do the collision. So you can have colors that are involved in the other bit planes, and you just don't need to check them, and so they will be, those colors will be ignored. But I think it does maybe make it slightly slower if that happens, or if you do though add the extra bit planes. I haven't benchmarked that, so I don't know for sure, but that is basically it. So we can see this color 1. So what I'm going to do is set it to a different color. So now we can see it's not actually, what we'll do actually would be a better thing for that is to just have color 1 for the border. Set color 1. So this is the color of the lines. So we'll actually, what we'll do is we'll bump that up to, so we make sure we don't use color 1 for the lines, so only for the background, only for the border. So you see that it should flash only when the sprites hit the border. And of course, WinUAE is just, the resolution's trying to switch when it changes color like that. So don't mind that. But you can see that it's just flashing the color. You have to trust me on that. It is just flashing the color when when one of the sprites hits the side. Okay. So yeah, that resolution switching is kind of annoying. But yeah, there you go. So yeah, it does it for each of the sprites. We can as well just check sprite 1, you know, or just we don't need to check all the sprites. I'm just doing it for all 3 there. But yeah, so you can see there that how to use that. That's a pretty simple way of doing collision detection when it's not what was I going to say? Yeah, but where you don't have to do the calculations yourself. It's kind of built-in collision detection. It's in hardware. So yeah, that is basically it. And what we'll do is we'll get rid of the playfield collisions, and so we'll only do sprite-to-sprite collisions. So let's see what that looks like. Of course, they're not really overlapping much, are they? But we are getting our reds and our greens and our blues. Yeah. So there you go. Now, any questions on that? Possibly not. That's fine. Oh. Sure. There's a quiet day today. Maybe yeah, I have made a mistake here by saying, oh yeah, I'll do a stream now. I've got my room back. And of course the Champions League final is on, which I wouldn't be too bothered with myself, like, meh. But I appreciate that a lot of people will be watching that. And also it's a Saturday night, people will be going out, people will be doing other stuff. That's fine. So, yeah, so that's kind of our sprite collision stuff, and I think that kind of I kind of leave it at that for sprites in general. But yes, this is very good, like this init shape and then shapes bitmap is very good for drawing to a shape and updating a shape. It works very well there for the sprite. You do have to bear in mind that basically your shape also has a cookie, and that's kind of, a cookie is just like sort of a template for your shape, and it shows the outline where the actual pixels are in your shape, and it's like, yeah, it's just like a single bit plane, kind of transparent and not transparent. And that's used for blitting so that you can see the background through it and all that. So without that, you get weird effects. Like, so when you draw directly to a shape like that, it doesn't update the cookie. And yeah, so ordinarily when you load a shape from disk, it will load the bitmap and it will create a cookie from that, and that works fine. So you don't need to worry about it. But if you're drawing directly to a shape like that, you have to use I think it's make cookie, yeah, and yeah, so, and you do make cookie 0. Now that's not important if you're using it for sprites, because they have their own separate transparency, and but if you're blitting, you need the cookie there to have the outline correct. And so if you change a shape, you have to do make cookie 0, and that will generate the new cookie for that shape. Yeah, clear as mud. Okie dokie. What I'll do is I'll keep that one open, but I'm going to move on to sound audio. Now I can't remember which of these. Ooh, let's see. Oh no, actually this was file access. Okay, so actually, yeah. So what I'll do some file access for this, because for most games you probably are going to want to deal with files in one way or another. So this is just a very, very simple thing for reading a text file. So you've got a read file function, and you always have to check whether a file has been opened or not, because you know, there's some of the commands that you should check, but you kind of, you know, like the window command and the screen command, you should check to make sure your screen exists before you start drawing to it, because if it doesn't exist, you're going to draw to, you know, all over RAM you shouldn't be touching. So yeah, it's always good to check. But yeah, but the read file, because so much can go wrong with reading a file, as in like it doesn't exist, it doesn't, you know, it's locked for whatever reason, doesn't have the right permissions. You always need to check, and you only deal with the file if you get a positive result. So what we're saying here is success is equal to read file, and you give the file an object ID, kind of like, you know, any other object. Like, so we're giving it a 0, and then you give it the file name, and that can be a variable. It's just hard coded here for this test file. So if you're able to open it, if the file exists and you're able to open it, then file input is the command, and what that does is that takes input from the file instead of from the shell window. So you know, instead of from the you know, typing in. So if you do so what we're doing here is, I'm going to skip the EOF for a second, but remember we did before the edit string. There's an edit function and edit string function, and they take input from the users, so that's fine. But what we have here is that they if you do file input and from whatever your file object number is, that will that gives you your that instead of taking the input from the keyboard, it takes it from the file, like a text file. So this is a text file actually, so I should have pointed that out as well. You can deal in binary files as well. I will deal with that some other, possibly later. But yeah, so basically this will take a string of up to 100 characters from the file, and that's all that does. So text string is equal to edit string 100, and it takes, if the line in the file is shorter than 100 characters, it'll just take whatever the full line is, and that's fine. And then we're printing it out. So this is literally just reading a file and then printing what's in the file, and that's it. But file input redirects the input from the program, which is normally the shell, and so things like edit string and edit take their input from the file instead. The converse of that is default input, and that changes it back to the shell or whatever, you know, is the default text stream on the machine, but that'll usually be the shell. So yes, that's it. Yeah, so you usually do that afterwards, because if you do an edit string and you don't have a file open, it will never receive any information, and your program will just hang there. So that's it. It might even crash, you know, because you don't have a file handle available, so it'll try to read nothing, and yeah, you probably bad news to do that. So that's it. The one other thing here is the EOF function. EOF is end of file, and so you give that file handle number, which is 0, you know, your file object, and all it does is EOF will return true if you're at the end of the file. So when you open a file with read file, it starts at the very start of the file, the first line of the file. So when the first edits that you do takes in the first line of the file, then the next one takes the next line, and it reads sequentially through the file from start to finish. When it has read everything in, and you try to and you run the EOF function, that will return true. Whereas if there's anything else after your position in the file, it will return false. So what we're doing here is we've got a while loop, and we will just keep on repeating this read a line, print a line, until you know, so long as EOF is false. So as soon as we hit the end of the file, that will be true, and this won't be executed. So if you are at the end of the file and you do an edit string, you'll just get 0 bytes. Like, so you will get input, but it's just 0 bytes, and that's it. So it's a null string, and that's it. And so then, yeah, it's usually good to give, like, you know, if you're expecting to open a file, usually good to give a bit of feedback if it didn't work. And that's, yeah, that's it. It's very simple file handling there. Let's see if this will work. Oh yeah, no, I think we're better off opening in this. very simply it will say that we can't open the file. Unable to open file. No, and because it's Blitz 2, it just goes straight back to the it goes straight back to the editor. Okay, so if we make a file in RAM called test.txt, blah 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 blah, and we'll save that. Test.txt, and so what we'll do is yeah, we'll add a little thing in here. Say, whoop. So this is just to wait for us to press enter. So just so it won't go back to the editor straight away. So now we run it, and you see we got our output, the contents of the file. Pretty simple. Simple stuff, simple stuff. And then we press enter and back to the editor. Okay, that makes sense. That is pretty handy. So what we'll do is, yeah, we'll go and work. We'll work through these examples and see what's going on. So this is how to make a file. And it's very similar. Basically, write file will open the file for writing. Now, if you use write file, you will overwrite the file that's there if it already exists. So you might want to check if it's already there, and there is an exists function for that. But yes, if you choose that, but it's basically the same format. You've got a file handle here, which is a file object number 0. File output 0 and then we just output 10 lines to it. So we can just run that. And we'll see now that our file is just 10 lines of, this is line 1, line 2, is exactly as we thought it would be. When we look at this code, this is line I. So we're just going through a loop 10 times. That's it. Very, very simple. And again, we have to redirect, and so this is what we do. File output is the equivalent command for writing a file to file input. It's fairly self-explanatory, I suppose. It redirects the output which you normally get from endprint. Instead of going to the shell, it goes to file object 0. And the reason you have you have to give it a 0 is you can have multiple files open, and so if you for whatever reason, you can have as many files open as you want, really. It's like shapes or bitmaps or screens or palettes. It's an ID number and they start at 0. So it's just kind of like always use 0. But yeah, you can use any number up to whatever the limit is in the Blitz settings. And you can see here, actually, we were talking about that earlier. So it's 5. You can have up to 5. But you can also increase that in the compiler settings. So that's writing a file, and that's basically the equivalent of the previous code that we saw. Again, you want to, after you close the file. Oh yeah, sorry, I should always say that you always have to close the file, because if you leave the file open, it's not a good thing. Close the file when you're finished with it. Because well, it's less of a big deal, I suppose, with hard drives, but with a floppy drive, the drive will keep spinning, and yeah, you don't really want that. And also, it stops anything else from using that file. So if you've got it open, you won't be able to edit it with anything else, or you won't be able to overwrite it. Another program can't write to it at the same time. So yeah, just remember to close your file. And yeah, so you close the file, and then default output instead of default input makes the output go back to being the normal shell output. And if you forget that, yeah, it's gonna cause you problems, because you'll try to write to a file that doesn't exist, and that won't be good. Or if you didn't close the file, you might end up, you know, just giving all this output into the file instead of what you know, instead of onto the shell, if that's what you wanted. So yeah, so default output just sets it back to there. There are also bitmap input and bitmap output, which do a similar thing. They redirect your endprints and your edits to and from a bitmap. Now, the edit string from a bitmap is slightly funky, but it you know, it works. But you can use that just for printing text on a screen where you don't have a shell output. But yeah, that's it. Yeah, very, very simple stuff. Let's go on to the next example here. Example 3. And what's the story here? Oh yeah, and this is, so if you were going to overwrite a file, so like I said earlier, if you go to write a file, it will overwrite the file. If it can, if it has permission to, and the file isn't already open or something like that. So, and it will do a write file. So what we're doing here is we're saying write flag equals true and a file name is the same file. And here's our function I was mentioning earlier. If exists fname string. So basically, if that file name exists, then we say file already exists, overwrite. And then we can say overwrite string is equal to edit string 1. So you can type yes for that. But it will only take the first letter. And what this function here, lcase string, basically converts it to lowercase. So we don't have to check for capital Y and a small y, or lowercase y. We just have to check for a y. So you can also do uppercase, ucase strings, and that will work as well. But then, yeah, so if it's anything other than y, we set this flag to false. And then we see that down here we get action cancelled by user is what happens there, because the next thing we do is check if the write flag is set to go. If we're ready to go, then it will try to open the file, and if it's successful, it will start outputting, or else it will say unable to write to the file, and then this else corresponds with that if there. So we can see action cancelled by user pops up there. So again, just to stop it going directly back to the editor. And because we already have that test file there, we should get file already exists, overwrite. And we go, no. Action cancelled by user. That's what we expected. And back to the editor. So we try again. File already exists, overwrite. Now, actually, what we should do is we'll put some rubbish in there so that we know it's different. So our file looks like this. It's got this garbage at the end. So if we overwrite it with a yes, why did that fall at the end without a... that's strange. Anyway, but we can see here that it's rewritten the file, and we don't have the garbage at the end because it's basically deleted the file and started from scratch. So this is what it has printed in there. But yeah, that is it. Does that make sense? Fair enough. Let me see, what was next? Example 4. Okay, now we're getting into the sounds. Now, this is the fun stuff. But let me know if there's anything you wanted me to cover on the file access. I don't think we'll do binary some of the time. I can probably dig up some binary, actually. You know what? We'll do binary now. So far we've been doing text. I think tutorial 12 covers yeah, binary files. Okay, so here we have long to write and word to write. So two variables. One's a long 32-bit variable and one is a 16-bit variable, and we just give them two values. So they're hex values there, A, B, C, D, 1, 2, 3, 4, 1A, 2B. Just two different a 32-bit hex and a 16-bit hex. Okay. So, and then we have a string to write. And we got our string size here. Now the len function returns the length of the string. So that's our string to write string. So our string size is captured in that variable, and then byte to write is 100. So these are just values to write. So if we want to write to this binary file, we do the same kind of thing. So it's read file and write file, but instead of using print, we are directly accessing what's in the file by using write mem. So what write mem does is that takes the actual contents of the memory that you give it. So the actual contents of the memory at a certain address, and whatever number of bytes it is, it will just write them to the file, to the given file. So the file number is 0. So that's it. So it will literally take those. See, so a long to write, we put an ampersand in front of that, and that returns the address of the variable. So it's not the variable that we give it, it's the address we want. So to get the address of a variable, you put an ampersand in front of it. So the long to write is 4 bytes because it's 32-bit. So we could just put a 4 in there, and that will be fine. But this is a little fancy function, size of, and that will return the number of bytes in a particular type, whether it's a new type or like a basic type. What's it called? Ooh. What's the name of it? Primitive. So here we have size of.l. That can be your .player or whatever, you know, and it'll give you the size of the new type in bytes. But the primitive here is a long, and so size of.l will give you 4, and size of.w will give you 2. And then what we're doing is we're going to write the size of the string as the next value, and then after that we'll write the actual string, and that's kind of a, and so you'll notice that the size of is a .l, so it's 4 bytes long. Even though the string might be very short, we always give it, well, you don't have to, but it's kind of convention to use that, because internally how a string is structured in memory is you've got your string, which is let's say whatever it is, hello world, and then the length is at the address, at the very start address of the string. 4 bytes before that are the length of the string, and it's the same in C and in Blitz. So basically you can actually get the length of a string by doing a peak.l address a string -4, and that's probably quicker than using the len function. I'm not sure if the len function actually does that or if it counts the characters. I don't know, but yeah, to be fair, I might be doing it a disservice. But basically, yeah, in memory, you've got the length as the previous 4 bytes from before the string address. So yeah, so we're going to store it in the file in the same way. So we write 4 bytes to it, which are the size of the string, and then after that we write the string, the actual string, and then we write the byte, and we do a size of .b, which is 1, and then we close the file and we finish. So it's very, very simple. You don't have to do file input, file output, because the write mem does a direct write to file. That's exactly what it's for. It doesn't write to the shell or anything, because that doesn't really make sense. Okay. So if we compile this and run it, and finished. Now what we have in the RAM disk is a file as test, and that is a hex file or a binary file. So what we'll do is we're going to open it in a binary editor. FileX is quite a good one. I like it. That's the one I use on the Amiga. And if we open it there, we can see here are the bytes that we put in there. ABCD 1 2 3 4 1A 2B 0000 000A. That there, those 4 bytes, that's the length of our string. and then we've got the actual string data here, and we can see it on the right hand pane there, testing, and that's you can see there that the ASCII codes for that string. And then we write 64 in hex, which is our single byte, which is 100. Like, yeah, so it's hex 64. It's decimal 100. Yeah, but yeah, that is FileX is quite a nice little text editor. It's well worth. Well, you know, I have it installed on all my machines because it is. Yeah, it's a competent hex editor. You know, no frills, just works. It's quite good. Yeah, so there you go. So that's writing a binary file. Reading, again, as you might expect, is very similar. So that's example 1. Example 2, I'm assuming, is the reading the file in. Yeah, so now we see we have all the same variables, but we've just initialized them as empty, so that's fine. And we're going to try and read that file in, and now we're doing a read file, read mem instead. Okay, so what we're doing here is reading to memory, and we're going to give it the address of that variable and size of that variable. So we are reading we are reading 4 bytes from that file and writing it directly to the address of that variable. So we're literally sort of poking those values into the variables. Be very careful with this, because if you get that address wrong, it will just write to whatever memory you give it. It doesn't check anything. It doesn't say whether you own it or not. If you give it the address of some of your code or some of the OS, it will just write all over it, and you don't want that to happen. So yeah, just be careful with it. Make sure you've got the right thing. Make sure you've got your ampersand there, because that is an instant crash. Because what you're doing there is you're going to write long value is 0. And so you're going to write whatever's in the file to address 0, and that is bad news. That's the exec base address. So that tells the OS where in memory exec is located, and yeah, that's instant crash. So be very careful with that. Yeah, very careful with that. What you cannot do really is you can't really load in a string in the same way, because the strings are dynamic, and so the space might not necessarily be there. So what you'll end up doing is, if the string is 100 characters long, you don't have ownership of that memory. So if you do a read mem and just like write 100 bytes into it, the computer won't thank you for that, and that could be writing over some other memory. You might get away with it, you might not, but that could be crashy as well. You know, so our string here is empty. So the string will exist, but it's just a case of whether the actual memory around that string is there or not. So yeah, you might get away with it with Blitz, because Blitz tends to use a sort of a scratch area for strings, like a string buffer, basically, that it sort of, you know, it deals with all strings in. But the better way to do that is to read read the size first, so we know how many bytes we have, because we wrote 4 bytes containing the size of it to the file, and then we start reading it 1 byte at a time, and just add that byte to the string. So that's all we're doing, and that will take care of having the correct length value stored in memory. It will take care of allocating the memory correctly and all that kind of stuff. So that's the way to do it. So we run a loop to the size of the string, read in the single character. So we see we've got a single char variable here, which is a byte size. So that's a single byte it reads in, and that'll be a single ASCII character. Then we add, and then we just take our string and we add on that character. And how we do that, so the actual single char is a numerical value, that's the ASCII value of that character. But what we do is chr string, a character string, and that will convert it into a string that can be added to the string, and that's how you build up your string. And then we read our byte, and then we close the file, and then we output the stuff there. So we'll give that a go, and we'll do the and we'll just add that so we can see what it actually produces. So now let's see if we can read in our file. So and again, this is a binary file, and we can see here we've read in the values. They're the same hex values that we put out, and the string is there intact, and that's it. So it works fine. Hopefully that makes sense to everybody. Yeah. But yes, do stop me if you have any questions on file access like that. But yeah, I think that's kind of it, because you know, with those basic techniques, like there are more things you can do, and especially in Amiga Blitz, you've got write type and read type, and you can output a whole new type in one line, one command, and it just, you know, it's very easy to do that. And that is handy for storing, like, you know, for storing save games or for storing particular structures. It makes it very, very easy. Of course, if you change the format of your new type, if you add a new variable to it, it messes up your file. But you just have to bear that in mind. If you're pretty sure your new type isn't going to change, then you can use write type and read type in Amiga Blitz 3. Whereas in Blitz 2, you need to go through each of the fields individually and write them or read them. So, yeah, so any questions on reading and writing files? I'm going to take that as a no. Okay, so I'm just going to check what the next example is. Example 2, because I think this one goes on to something else. Oh, byte order swapping. Oh, that's fun. I did mention this before. I did mention this in the Discord for any. Yeah, someone was asking about this and whether to use big Endian or little Endian. Let's have a little chat about this. So, basically, this is. This is showing you basically when you've got a value that's more than 1 byte in size, so a word or a long word, you know, so if it's more than 8 bits long, then you're a value. How it's stored in memory depends essentially on the CPU, and there are basically the two main families, and big Endian and little Endian. And so big Endian is. Oh, let me get this straight now. I just want to make sure, because I do end up confusing myself with this. But big Endian is basically, well, the Amiga is big Endian, but basically all Motorola chips are big Endian, as in, so in the 8 bits, you've got the 6809 that's in the Dragon and a couple of other odd computers, but in my mind, I prefer the big Endian format, and I think it's easier as a person to read it in memory and to deal with it in code. But it makes the CPU a little bit more complicated, and it suits CPU design to use little Endian, which is the opposite way around. So what basically what big Endian means is that you've got the biggest part of the number is first. So, like, our own decimal number system will be big Endian. So, in its way, like, as in the most important part of the number is first, then the second most. So your hundreds are first, then your tens, then your ones. It's something like that for for big Endian or little Endian. And what happens is you've got the most significant byte first, then the next least. Then the next most significant byte, all the way down to the least significant byte, and they read left to right as we read naturally, and that, so it makes it easier for us to read, looking at code. But if you have a little Endian CPU, it stores the smallest byte first, and then goes towards the largest byte, or the most important byte, the most significant byte, as they say. So that is you're talking Endianness, and the little Endian CPUs are basically everything else. Well, like obviously the key ones are the Intel x86 and x64. They're little Endian. And the 6502 is little Endian. And the Z80, the 6502 and the Z80 are little Endian. So you have to bear that in mind when you're dealing with binary, dealing with hex, that the bytes will be swapped in values. Like, so 16-bit value will be the opposite. It will look the opposite way around. Now, obviously, the CPU is designed that way, and the low-level access functions are all designed that way. So it doesn't really make a difference to the end user. But when you're actually dealing with binary files and binary values, you kind of need to, you just need to be aware of that, especially if you're transferring data between systems. So what we have here is this little function returns a long, and all we do is we give it a value, store in the value variable, and we set up a result. So basically we take the least significant byte, which is these ones. So this is ampersand here means the binary and logical and. So sorry, a bitwise and so what that means is that the result is basically going to be the and of value and that. So what it'll do is, because these are all zeros and these are all ones, or F is like 1 1 1 1 in F in hex is, or F hex value in binary is 1 1 1 1. So these are all zeros, and the last byte here is 8 bits of ones. What that will do is that will take the value in value, and it will only return the least significant byte, and then it shifts it left by 24 bits. So that shifts it all the way over 24 bits to the right or to the left. So that makes it the most significant. It makes it the leftmost byte. Then we do that for the middle one, and we move it 8 to the left. Then we take this byte, and we move it 8 to the right, and we finally take the leftmost byte of value, and we move it 24 bits to the right, making it the least significant byte. And that's it. So we can see here A, B, C, D, 1, 2, 3, 4 is the value, and basically we'll swap that long value and store it in long swapped with that function. So let's see what that looks like. And we'll just so that we can. Oh, garbage is end of line. Oddness. Okay, so the value we gave it, A, B, C, D, 1, 2, 3, 4. You can see here, 3, 4 is our first byte. 1, 2, C, D, A, B. So you can see how it's less kind of human readable, but as far as CPUs are concerned, and with certain code, code-wise, it makes sense in certain circumstances to use little Endian. So they both have their pros and cons, but I much prefer working with big Endian stuff. So there you go. I hope that makes sense. It's probably not of a huge amount of use for what we're doing, but it could come into play if you're creating files on a PC that are naturally little Endian. If a binary file that whatever, like a map file or something like that on the PC, it might end up being little Endian, and then you can read it and use a function like that to swap the orders. Yeah, that's it. If given the option, of course, you would create it in big Endian format, so that you can just read it straight without having to do this jiggery pokery. Okay, let's see what's next. That was a little surprise. Okay, The requesters are here, but I'm going to leave requesters for another time and dealing with you know, OS functions and stuff like that. So that was that. So what we're going to do is we're going to go to some sound, and I think that was example 4, wasn't it? Playing sounds. Yes, here we go. So this is now where we get where we get into the fun stuff for adding sounds to your games. Now, like all other, or almost all other Blitz objects, you give a sound an ID. So in this case, we're giving this sound a 2, and Blitz only understands 8 SVX. That's the standard IFF 8-bit format. Okay, so just bear in mind that it's kind of limited, but it does understand them. It fully understands the like the standard frequency and stuff that it's to be played at, and we'll load in all that extra data with it. That's fine. What that does, yeah. So we're just giving it an ID of 2. That's it. So then the sound command is what plays it, and it's very simply, well, yeah, the simple bit is giving it the sound ID to play. Then channel mask. This is basically a number that tells it what channels to play it on. So you know the Amiga hardware has 4 8-bit channels. So 1, 2, 3, 4, and they play like from I think they're left, right, right, left. So 2 of them. So the 2 outermost ones I think are the left, and the 2 innermost channels. So 0 and 3 are left, and 1 and 2 are right. So they're combined internally to make your 2 stereo channels. So this basically is you know, a percent sign like that tells us that we're dealing with a binary number. So we want to give that, play this on basically channel 0 and 2. And what we're doing here is we are doing it's an optional thing. So normally if you play the sound, it will just play them at maximum volume, which is 64. But what I'm doing here is, you can, for every channel that's switched on, like we've got 2 channels switched on here, so channel 0 and channel 2, and for each channel that's switched on, sorry, we can optionally give it a volume value. So what I'm doing here is I'm giving the right speaker a 0 volume and the left speaker full volume. And now what we're going to do is then we play this little loop here, and what that does is that will change the volume. So you've got a volume command there, and that just sets the volume of that particular channel mask. You can see it's the same channel mask. So we're going to take 1 left and 1 right channel, and we're going to set them to I, and then 64 minus I. So what will happen is we start with the channel volumes like that, and we just move 1 up and 1 down like that, and that's it. And we just put a V wait 4 so it doesn't happen instantly. So it takes place over a few seconds. So if you're listening in stereo, you should be able to hear the difference here, and you can hear it panning across to the left from the right, and that's it. So you know, that's kind of, you know, even showing you a little bit of an extra trick. But just to play a sound, you just choose your channel, you know, in binary. You don't need that volume really strictly, but that's it. You just choose your sound and choose your channel. Now like I said, the format has to be 8SVX, which is the standard 8-bit IFF format. There are loads of converters around. You know, it's the same format that like any of the trackers and stuff will use, and that's fine. If you're trying to find sounds from the internet, or you're making them on Windows and stuff like that, you might not be able to save them as 8SVX format, and Blitz won't understand a WAV or you know, or any kind of compressed audio. Won't understand anything like that. So just bear that in mind. Now, I got this these sounds from the internet and converted them on the Amiga. And so, you know, it is a nice way of doing it, but basically hardware-wise, like I should go back here and show you this. I'm going to actually load that in here. Hardware-wise, we've got our 4 channels. The frequency that you can play is only up to about 26 kilohertz. Let me think. What is it? 56. Well, sorry, about 28 kilohertz. Okay. So that is basically a limitation of the hardware when you're running the normal Amiga screen modes. If you use a double scan mode, you can actually produce sound at 56 kilohertz, which is sort of more than enough for the bitrate of for the sample frequency of a CD file. Now, obviously, it's only 8-bit, but you know that's the kind of you can get a lot of quality by using higher frequency samples. And this is the thing: when you're playing sounds like this, they're loaded into chip RAM. So if you've got a lot of chip RAM spare, use the best quality version of the sound effect that you can. So that will be up to 26 kilohertz if you can get it, or up to 22 is kind of common because a lot of sound effects you'll find and a lot of software will use 44.1 kilohertz because that's the standard CD frequency. So half that 22050 hertz, and that is a good, it's a reasonable standard of sample. It was a thing that because the sound, the audio is DMA driven, it's not really a big deal to be playing higher frequencies. The only sort of trade-off, the only downside of using high frequencies is increased file size and increased chip RAM usage. So that's all it is. So, but yeah, use the highest quality you can within limits, obviously, of the 26 kilohertz, because yeah, back in the day, you got a lot of games and stuff that had really poor quality samples, and they were cropped really short, and that was to fit them all on disc or to fit them all in chip RAM. And it's kind of like when you play these games now and you kind of think, oh, that's a bit rubbish sounding, so some are better than others, obviously, but you can get a very, very good sound quality from 8-bit sounds at 22 kilohertz. Now I'm sure you heard that church bells thing, but I'll run it again just so you can hear it. And I might actually pause the music and we'll run it again. So you can hear yeah, you can hear that it's not full quality, but there's very little in the way of ringing and stuff like that. So sometimes you get samples and they have a lot of ringing in them because they're running at a very low frequency, like 6 or 7 kilohertz or something like that, and yeah, they sound a bit rubbish. But that sample, that's a sample I got from the internet, and it is originally a 44 kilohertz sample. I converted it to 22 kilohertz, I think, and that's what it's playing there. So it's quite a good quality. Now, yeah, for RAM usage and disk space usage, sound effects are basically is one with 8-bit samples is 1 byte per per data point. So if your sample is 22 kilohertz, 1 second will take up 22k of RAM. So if the sample is only half a second long, you'd take 11 kilobytes of RAM for that sample. If it's 10 seconds long, it'll be 220 kilobytes of RAM, and then you might start to be running out of chip RAM pretty quickly. But yeah, there's software that I use to convert that is I'm going to find it here now. Where is it? Sound is Sample Z. And it is quirky, to say the least, interface-wise. I'll show you what it looks like now. It basically just plonks windows everywhere. but it works very well. It's funky to use, but it resamples things quite well. It does kind of, normalization, and you can, adjust volume and stuff like that to get the best of it. So what you really want to do is you want to have a sample that's using as much of the sort of space as it can. So if you're working on PC or something like that, you want to normalize it to use basically all of your data range and then convert it to 8-bit, because you lose so much more information when you're, scaling in 8-bit that, very quickly you'll kind of lose quality by messing with a sample. So you want to keep it in its original 16-bit format for as long as possible, and 44 kilohertz for as long as possible, and then convert it down when you've finally got it. But yeah, this Sample Z software, you can do frequency conversions. It can load and save a few different formats, so that works quite well. But yeah, the interface is just a little bit weird. But yeah, there you go. So let's see what if we. I'm trying to remember. So we have to add a sample, or no, sorry, we load a sample here. This is what we want to do. So let's just say we're going to do that same one. And there it goes. What are we on? Tutorial 10? Nope, 11. And hey, Prince Phase, how are you? Welcome along. Yes, they are. I will throw the YouTube link in here now. I add them to YouTube like a couple of days after the stream. They're all on the Twitch channel as well. So you can watch them on Twitch for a while. All on my Twitch channel. You can see them in my history. But I have a playlist on YouTube. They do disappear from Twitch eventually, and I will give you that link now. And that's it. So there are 4 parts. This is the 5th part here. Yeah, so that's where you'll find them. It'll be a couple of days, like I said before, this one shows up there, but all the previous 4 are there now. Yeah, so you can see here, like, let's say we let's load the WAV version. Oh, it's the same part 4. Oh, I never changed that. Sorry, guys. Yeah. Let me see. Where's the window now? I'm not sure. Too late now. Let's change it to part 5. Oops. Yeah, I've updated it now. It's a bit late at this point, but yeah, sorry about that. Cheers. And what's happened here? Oh yeah, no, we didn't want it. We lost our place there, didn't we? Load. Shared articles, tutorial 11. Okay, so here we can see our sample here, and we can play it. So you can have loads of samples that you're working on at the time and in there, and that's fine. So if we play that, that's the original sample. And yeah, so we can, and then we can, if we look at our frequency here, we want to choose from frequency 44,100 to 22,050. And yeah, so what we do is we just select everything, mark all. And so you can do a certain part of the, you can adjust volume and stuff like that. So, well, actually, before we do that, what we'll do is we'll do our volume editing. So, so basically, it's saying it's near to the maximum anyway. So it's saying 112 % is what the absolute maximum would be. So at 100%, it's slightly lower than the full range of the values. So if we do volume, we'll see it got slightly bigger there. No, this isn't. This is on AmiNet. This is Sample Z, and it is on AmiNet. It's slightly funky software, but it works really well, and it is it's what I use for converting samples and trying to get as good quality as possible for use with Blitz. So the example I have here, the church bells, I have converted that already, but I'll just like reconvert it here. So you can see here, we've done it, and that should be as loud as it can be without getting distortion. Now we'll do our frequency, and I can't remember with or without oversampling. The documentation will tell you which one's better, but let's do it with oversampling. So now if we play it, we'll have a, you'll hear that it's actually running at half speed because we've slowed it down, and we're expecting 44.1 kilohertz. So if we set the actual sample frequency to 22050, what have I done here? Oh, I should have set that to 22050 to start with. But yes, sorry. From 4400. Oh, have I done this backwards? I think that's what I've done. So I've actually doubled the frequency. Yeah. Anyways, yeah. See, this is slightly funky software in that kind of way. A list of tools I'd use with Blitz. I don't really. It's kind of like I just kind of talk about things when I'm going. So, but I'll tell you what I use for my games and stuff. I will use this for my sound. I will use Personal Paint usually for converting the graphics, or for for creating graphics and editing them. What else? I think that's kind of it. There are other things as I need, like I did show editing a hex file or binary files and reading and writing binary files there a little while ago. I'm not sure if you saw that bit, but I use FileX for that, and that's there. That's quite a good little hex editor. That's kind of it. Yeah. So, but yeah, that's basically it. So, well, what I'll have to do is I should load that file again. Do I have an undo on this? I can't remember. Functions. Yeah. No. Fine. No, I think it would have to start again with this one. So we'll delete that one. We'll load that file again. So we can see that's it again. So we'll select all. We'll do a volume. Volume, fine. And yes, now do with oversampling. And now we see it's playing at double speed because it's a 22 kilohertz sample and we're playing it at 44.1. So when we set it to 22050, that's the normal speed, and that sounds exactly the same except it's half the frequency, so we have lost a bit of quality there. This is running in an emulator. I would normally do like if I'm streaming games and stuff like that, I'd normally use the real hardware. It's just a bit easier for when you're doing a bit of coding to have it on WinUAE, and just because of crashing and stuff like that, but also because yeah, just it's nice to have. I usually use, when I'm developing this kind of stuff, I tend to have like a higher resolution. I use a graphics card or something like that. But for system unfriendly software like again in Blitz, it's nice to be able to basically run a graphics kind of thing. There's my Blitz environments there. To run a graphics program that bangs the hardware directly, and it just it's already set up in the window, and it doesn't it's easy enough to do. It's easy enough to stream it like that without changing screen modes too much. So yeah, it's I know it's sort of like a slight cheat, but for development as well as that, when you get a crash, which it will inevitably happen, it's very quick to reboot and to get going again. and for especially for this kind of thing where you're transferring data in and out. You might be transferring graphics or sound from yeah, there you go. If you're transferring graphics and sound from the PC side, it's it's having a shared folder like that you can just like drop stuff in, download assets or whatever from like Open Game Art. I'm a big fan of. Just drop them into the shared folder, and then yeah, that's it. So it's much easier than putting them on disks or putting them on a compact flash and transferring them across. Like it's worth it. But yeah, so that's why I tend to use WinUAE for this. But yeah, so that is how I deal with my samples. So it's kind of a slightly funky tool to use. It's some bits are counterintuitive, but it's decent. And then we can save that and we can choose our format, 8SVX. And oh yeah, we're still in 16-bit there as well, of course. So we'll have to yeah, when you save it, it will convert it to an 8-bit file. 8-bit mono, and we don't really need to change the stereo or anything like that, because basically when you're playing a file in Blitz, it'll only do a mono file. So that's it, and then you can choose to save it as a different name. So obviously don't save it over your original. That's it's going to ruin your day, I think. But it depends on what it is. But if you spent a lot of time actually working on a file and then you erase it's kind of like the master, if you like. It's not fun. It's like compiling into your code file, It's a mistake you'll only do once. But yeah, so it's funky interface, but it's quite good. I like it. I use it for, like I say, for my projects. And yes, Sample Z it's called. So yeah, so this code here. Sorry about the flickering. I'm not sure if you saw that there, but it will play that sample and it'll pan it across from right to left, and that's all it's doing. It's very simple. And we've got and it's just a sound command, and we're playing with volume there, so we don't even need that. Basically, what all you do is you use a sound command, and that loads the sound loads the Paula registers with what they need to play the sound, and sets up all the DMA and stuff like that, and then it will go and do its own thing. So the sound command executes immediately, and your code can carry on. You don't have to wait for the sound to finish playing. So that's what will happen, is it will keep playing until it hits the end of the sample. So that's that's great. You do your sound effect, you just kind of fire and forget. That's it. If you want to stop a sample, you can play another sample on that channel, and that will interrupt the currently playing sample and immediately start playing the next one. Or you can set the volume to 0. To actually stop a sound from playing, you can poke at the registers, but there isn't a direct Blitz command to do that. But yeah, usually you can just set volume 0 for that particular channel, and that's a simple, it's a simple way of doing that. Okay, what's next? So yeah, so that's the basics of a sound. So example 4. Let's see what example 5 was. Now, yes. So here's some fun stuff with changing the pitch. So so what it'll do is it will play every 8-bit sound, like in 8SVX format, in IFF format, will have a standard pitch that it's meant to be played at, and Blitz will play it at that pitch. And so in kind of in machine terms, or in actual internals terms, that's the period rather than the frequency. And what that is basically how long to wait between playing the next data point of the sample. So that's it. So the shorter the period, the higher the pitch, and the faster it plays. And that's it. Now you can change the pitch you can change the period, which changes the pitch, using set period, and that basically changes the period for that particular sound object, and then when you play it, it will be played with the new pitch in mind. Now, we've got a couple of extra fun commands here. So run errors off and run errors on are because the set period command triggers the debugger, even though there's nothing wrong with it. So if you don't use the debugger, it won't matter. But what this does is this just disables the debugger and then enables it again, because it's quite annoying for the debugger to complain about it when there's nothing wrong with it. Illegal channel mask. It doesn't take, this is the thing, it's not supposed to take a channel mask. It's supposed to take a sample object number, which 2 is. So yeah, there's nothing wrong with that. So you just disable the debugger, let it do its thing, and that's it. So so what you're setting here is the period of the sample object, not the actual hardware audio channel. And that's important to remember, because what'll happen is this takes effect the next time you play the sample. So it doesn't take effect when the sample is actually playing. So if the sample is already playing, set period command doesn't do anything. It only changes what will happen the next time you run that sound with the sound command. So let's have a look at what that sounds like. So you see it's a higher frequency than it was before. And you notice that the debugger didn't complain. So just for comparison, if we don't have that in there, there's the normal speed, or the normal period, and that's it. So that sets the period, the frequency, I suppose. And yeah, and what we're doing is we're playing it on 2 channels, so it's playing left and right the same. You notice we don't have any volume parameters. So it's just playing maximum volume on left and right. So so both speakers will get it. Obviously, you've only got 4 channels, and if you've got a lot going on, or if you're playing music, you'll have to you'll have to bear in mind that there are only 4 samples you can play at a time, sound effects and music combined. So just bear that in mind. You have to do some juggling. Yeah, what you'd usually do is you'd have sort of either a low priority kind of part of the music that you can kind of say, well, it's not the end of the world if that channel disappears, or you can have your music on 2 channels, or let's say, compose the music that way, compose your tracker module that way, and then you can use 2 channels for sound effects. But yeah, it's nice if you have let's say 2 channels, or if you're using all 4 for sound effects, it's an idea to sort of work out what would be a higher priority. Like, so there might be a big explosion sound that you don't want to interrupt, and you want to give that its own sort of dedicated channel, or so basically the only thing that will interrupt the explosion is another explosion on that same channel. So you don't want the big explosion to be interrupted by a little bullet when you've got hundreds of bullets flying around, and because then you'll never hear the explosion. You'll hear the first little bit of it, and then it'll stop. So yeah, so just it's kind of depending on the design of the game, and depending on how many sounds you have and how many are going to be triggered at once, you can usually sort of like work out a compromise of like, it's not a big deal if you can't hear the bullets when the explosion's going, so just don't play them, or put them on a separate channel, or that's these are decisions to make during development. But yeah, for this, because I'm only playing the 1 sample, I'm playing it on left and right speakers. So we can do 1 1 1 1, for example, and that will play the same on all 4 channels. And what you'll end up then is it'll be slightly louder in both speakers, because of course the Amiga has this hard panning thing going on. So if you do play it in just 1 speaker, it will only be in that 1 speaker. You won't hear any of it on the other speaker. So just bear that in mind. And that's it. So that sets the frequency of a sound effect object, and then whenever it's played, it will have that higher frequency or the lower frequency. To change the actual pitch of a sample while it's playing is a bit different. So if you have, like, let's say an engine sound and you're accelerating, and the pitch goes, you know, continuously changes. So, you know, what you could do is change the pitch of the engine sound and start playing it again, but that's messy, you know, and it won't be smooth. So instead of that, what we have here is, and yeah, again, ignore all this stuff. That's kind of like basically the Amiga Blitz 3 extra stuff that gets stored in the file, and Blitz 2 doesn't understand, but it doesn't matter. It's just comments, so it doesn't matter. So we're loading the same sound now. This is doing the same thing as the set period. Sorry, before I get onto changing the pitch while it's running, this is changing the period of the sample. It's doing the very same thing as set period, but it doesn't trigger the debugger. So you can do it one way or the other way, and this way is basically what you're doing is you're poking the period directly into the sound object, the Blitz sound object. So it does the same thing as set period, but it doesn't involve messing with the debugger. Type.found. Okay, so, and what we have here is these are the Blitz Basic object types. So you'll notice that I haven't defined this new type, or this struct. I haven't defined that. So all it is happy birthday. Anyways, so you just have to add that to the Blitz Basic. Hey, Friar, welcome along. Good evening. Good evening. How are you? And yeah, so that should compile now. Yeah. And you here now. Yeah, I'm grand. I'm a little bit hungover. I'm not gonna lie. I had a work party last night, and the end of a big project, and I'm a little bit rough all day because of that. But it's fine. It's fine. I've got my water. I'm nearly out of water actually. But yeah, that's it. Yeah. And normally for a weekend stream I'd have a couple of beers on the go, but yeah, no such luck today. But anyway, you can see that we've extended this we've slowed down the period of that sound. So like we've basically by putting in 500 into my sound. So that's it. So, and we saw, what was it, 230 or something like that was the original, or 324, sorry. So that's what it was, 324. And that's how we can, and there isn't a way of getting the period. So we were using set period in the previous example to change the frequency, or change the period. But this, because if you load it as a pointer and a struct, that we went through in previous things, we can actually read the value directly, and that's it there, and we can write it directly. Now, if you look at this code in the Amiga Blitz 3, and one of the reasons I try to use Amiga Blitz 3 instead, it is much easier to read. Let's see. So, or it's nicer to use. So what happens is we are going to make sure the debugger is not on. And but what we can do then is we can look at the struct here in the browser, and you can see, so you can see the subfields that it has. So when you assign a pointer like here, so my sound is a pointer that we've made of the sound type, and we just point that at the address of sound object 2. That's what the ADDR function there does. It just takes the given object, whatever object it could be, a bitmap, could be a sound object, whatever, but it's the Blitz object, not the actual audio data, or not the raw data, or not the file that's been loaded. So, but that points at that then, and then we can see that my sound underscore data, that's a pointer to the actual data. and period is obviously the basically the time between each data point on the sample, and then length is length, and loop and loop length are basically in the IFF format you've got the possibility for having for repeating a section of the sample, and loop and loop length are basically like the start and input and length of the are the start and end points of the repeated section. So that's it. Does that make sense? So, but basically, yeah. So what you can do is you can access all the information there if you wanted. Like my sound backslash, and you're limited to a 64 kilobyte sample, by the way, I think, with this anyway, because it seems to be giving words, like, so the length can only be a word variable. Yeah, so yeah, so I think you're limited to that for this anyway. So you can see here length, okay, -3. So that sample is actually longer, so it'll play longer samples. It just doesn't seem to deal with it well. But anyways, yes, you can access the data there, and then the pad byte at the end. Don't know what story is that, but I guess it's to give it an even end. So if you load more samples, or more objects. But anyways, yes. So that is how you can change the sound period without using the set period command, and therefore without using the debugger workaround, but also how to access information about the sample. Let's look at the next example. So example 7. Now, this is what I thought the previous one was, but is actually changing the frequency of the sample while it's actually playing. Now, this is different because you're not changing the frequency of the object. So the sound object is object 2. That's still playing, and that's unchanged. What you're changing here is you're actually accessing the hardware directly, and you're changing the period on the fly of whatever channel it is. So so basically you can see this has the channel mask. That's the same number as the sound is playing, so you can choose which channels you want to change the frequency of, which of the 4 channels. That's the channel mask, and then the period is that. So what we're doing is we're going to go from 200 to 350 in the period, which will slow the sound down as it's playing, and just with a little 2-frame delay in between to so it doesn't happen instantly. And that will sound like, there you go. Very sad church bells. Now, does that make sense to people? Everyone happy with that? Any questions on that end of things? Because that's basically all there is to sound, pretty much. Like the basic sounds like that. I did frequency, I think, is in one of the extended libraries. It should be pretty standard in most Blitz add-ons. You can see it Elmore hardware lib. But what you can do is, I've just got it in here instead, is these are chipset registers, and Prince Phase will be familiar with these, of course, from doing assembly coding. But basically these are the hardware addresses of that contain the period of each channel, and they're like, so accessing them directly will do the very same thing. So frequency is just doing that kind of in a neat package where you can do it to multiple channels at the same time, but all it's doing in the background is the same thing. So we run that, and we've got a church bell slowing down again. Yeah, so Yeah, the hardcore types will be liking that. But yeah, frequency just gives it a nice, neat wrapper. But it's not one of the standard Blitz commands. So if you load the very, very basic version of Blitz from floppy disk, you won't have that. But every other version of, you're really running quite a limited version of Blitz if you're in that situation. Most people will have the freak command there, so it's probably neater and more basic like to do that way, I suppose. But yeah, so that's I don't know if you were here for the start of doing the sound or any of the other stuff, Ian, but if you want me to go over anything again, do you want, or are you happy enough with that? Because it is fairly simple. The basic concepts are: you load it as an object the same as, yeah, cool, grand. You load it as an object the same as any other, like a bitmap or a shape or whatever, and then you use that object with the sound command, and you set a channel mask, and they are the 4 hardware audio channels, and you can choose whichever channels you want to play it on. If there's something already playing on one of those channels, it will stop playing and immediately switch over to the new one. So that's it, simple enough. And then you have to change it on the fly, frequency, and you just change the period then with that. There you go. I don't have anything really prepared for music, for playing mods, and it was just something that was asked. You can't really queue stuff up. No, if you use the sound command, it will directly start. It will immediately start playing that sound. So to queue it up, basically you need to check one of now I can't remember the register. But there's a register you can check that will tell you whether the channel's busy or not. But you have to, basically that's it, and it immediately changes Paula to start running the DMA on that sample data straight away, and it will run until the sample's finished. But there's a register on Paula that you can read, and it will tell you if each channel is busy. So if you check if a channel is busy, that will tell you that it's still playing a sample. So if you check that, so basically in your main loop, you could check that once a loop, and see if you have this stuff queued up yourself, you can you kind of have to like do the queue yourself, I suppose. But if you want to play a sample, you just set a flag and check each game loop until that register says it's not busy, and then play it. That's basically how you do it. There would be. I have let me think. There is a very good website that has all the good hardware addresses. Oh, I'm trying to remember what it's called. Prince Faze would probably know it off the top of his head. Let me see. Copper Shade, yes, thank you, Copper Shade. So here is the complete. Oh, Spike, how are you? Welcome along. Yeah, Amiga Dev.ilhour. Oh yes, and I'm links are not allowed. I should switch that off actually. I don't get too much spam in here. But there's a complete list of the registers. Now, the reason I have posted that one, and Amiga Dev has all those registers as well, and it has very good information on the hardware, like the audio hardware, all the registers involved. It's very, very good, I have to say. But the reason I put the Copper Shade one is that it also includes the AGA registers, which are not in the original hardware documentation, because the idea was Commodore didn't really want people doing the accessing the hardware directly for AGA. They wanted to go through the system. Of course, that was, people figured out the way around it. Yes, that's a good one as well. Yes, and that is a nice setup of registers as well. Very good, very good. It is slightly more organized in function wise and stuff like that. But yeah, that's very good. Thank you. There you go. But anyways, you can see in there, and I can't remember audio. I can't remember which register you read to see if the channel's busy. I can't remember. I'm just having a quick flip through here to see. I can't remember. Does anyone remember? Do you remember, Prince Phase? There is, and it's basically just you check a flag and it will tell you if there's DMA active on that particular audio channel. And I can't remember what it is. But yeah, that's basically how you do it. You check that, and if it's busy, then you can wait. But you have to kind of do that yourself. I can't remember. Anyways, yes, it's usually people don't bother with queuing up sounds like that because sound. yeah, it's like it's one of these things. Like I did it and I put it in code and then I gone. But yeah, that's it. I kind of forgot about it then after that. But yeah, it is fairly straightforward to do. But yeah, like to be fair, usually you want sound effects to be instant. You see, so so like let's say gunshot or collision or whatever, the sound effects usually straight away. And so you'll notice that in a lot of Amiga games, of course, because of the limited hardware, that it just cuts in on top of whatever is already on that channel. So that's why if you got a load of explosions, they don't roll one over another. They just like one stops instantly, the next one starts, because you just have them running on the one channel. So it is yeah, kind of a bit limited. It's probably not a huge use case to wait until the until the sample's finished before you play the next one. Usually things are kind of more instant. But yeah, it is a very good question. And yeah, one that I haven't really been able to answer. But yeah, there's a DMA register, and you just check to see if it's running or not, and that's it. I'm sure a bit of googling will find it, and it probably is in the hardware reference manual actually. Let me see, just for curiosity. Oh, my audio hardware. Let me see. Audio state machine. Yeah, no, that's fair enough. So yeah. Let me see. Okay, they're bits 0 to 3 in DMA con. So that's a general purpose kind of, it's all the DMA that it has flags for. And so bits 0 to 3 are the audio channels. Yeah, so you can check it there. Now, there is a note here saying that they're for channels 3 to 0. So I think by the sounds of it, like bit 3 is audio channel 0. Or X equals 3. Oh no, it's actually yeah, but you've got the DMA con OR. So if you read the registers, like, okay, they're two separate registers because one's read only, one's write only. But if you read the read version of that tells you that it is enabled, doesn't it? Because what will happen is the DMA will be disabled once the sample's finished. Or am I now misunderstanding it now? Or am I misremembering it? Let me see. DMA Just indicate channel number. Yeah, so you are right that it is, it's a sort of one of these funny registers where there's a read version and a write version of it. But yes. Let me see. In DMI, let's see. But yeah, I think. Let me see. Anyway, yeah, no, I will leave it there. But basically, yeah, that might not be it. Just bear that in mind. Worth experimenting. If you're reading the registers, you won't do too much harm. But that seems to be. I think that was it. Anyways, yeah. Yeah, there we go. Okay, now, so anyways, let's carry on with something else. What else was there? Now, yeah, to talk about music and stuff like that. I don't have any code handy for an easy kind of demonstration of music, but basically at the moment there is a kind of the relatively up to date mod player library, which is the PHX library. And that is there's a Blitz Basic port of that if you like. It's slightly funky, and because it keeps changing, it depends on what version of the library that you have, how you actually use it. So I'll have to kind of sit down with it beforehand and do a proper kind of run through of it myself before I kind of want to talk about it too much. But essentially, that's a very good library because you can use that to play music and sound effects. And what you do is you kind of give it a channel that has priority for sound effects. Aha. Okay, so it's saying that the interrupts are firing. Okay. Thank you, Prince Phase. Thank you for that. Yes. Okay. Thank you very much. But yes. So. Yeah, and you read that then, and it'll say whether the channel's busy or not. Okay. Or whether the interrupts are enabled on that channel. Yeah. So if you're using the PHX library, like you don't have it with the standard Blitz 2 install. You have it with the latest Amiga Blitz 3 versions come with it. So bits 7 to 10. Oh, cool. Thank you. So you have it with the Amiga Blitz 3 installs, the latest ones, but you can add it to Blitz 2, and there if you look, there's a thread on EAB about using this library with Blitz. But because it's kind of still under development, there are like I said, there's a couple of versions knocking around, and how you use them, the actual commands you use are a bit different because you have to do certain things in a certain sequence, and some of them you need extra commands, some of them you don't. But yeah, just bear that in mind as well. But it is a good library to use, and because what it does is, yeah, like I was saying, you give it a priority. You give one channel a priority for sound effects, and that can be like a channel that doesn't have a significant portion of the music on it, let's say, or a background instrument, not the melody instrument or whatever. And so your sound effects will play over that, and it will also. It's also good just to use for sound effects because what it will do is it will play on kind of like the next free channel. So so if it's got free channels, it takes that into account, and so you can kind of start a new sample without interrupting the previous sample, and it's nicely done. It's a nice library to use for sound. But like I said, it is a bit funky, and I want to sit down with it beforehand to know for sure that that's what I should be doing. So I think that was it for the sound then, wasn't it? Example 7, yeah. So and then this is other funky stuff. Oh yeah, we already covered this, which is reading and writing binary files. Yes, and I will probably cover that as well because adding libraries to Blitz 2 is a little bit involved, and to Amiga Blitz to be fair. But yeah, because you can download the library, but Blitz doesn't actually use it, so you kind of have to rebuild the what's called the deflibs file, and that's what holds all the main commands that you use. So there's a little bit of a process to that, but I'll go through that maybe in the next stream, I think, and once I've had a practice run myself and don't completely embarrass myself, and so that will do it. Yeah, I won't do that now. Now I don't know if there was anything. What else did I say I was going to cover in this? I did file access. I did sprite playfield collisions and sprite collisions, and that was it. But I'm going to get a little snack and a glass of water. Have a think if there's anything you want me to cover, or recap. Let me know. But I'll be back in a couple of minutes. How is? So any requests on or to go over anything that I've done in the last while, or anything in general? Cool. Well, what I'm actually doing here is I'm working through the tutorials that I wrote a few years ago for Amiga Future Magic magazine, and they did culminate in a Tron game. Let's see if it's even going to work. We can open it here and have a look. So basically, AF-Tron, and this was the code for the game. I don't even know if this will run or not. But let's give it a go. Oh yeah, no, this is bad news. Whoa! Let's reboot. See, I'm running Blitz Basic and Amiga Blitz at the same time, and that's kind of a no-no for the debugger, because the two debuggers are quite different and they basically kill each other. So I tried turning it off there, but the Blitz 2 debugger picked up on the Amiga Blitz 3 code running, which is not what you want. But yes, I'm going to see if this actually works. 2018, it turns out. Let me see. Oh, it was right. Oh, why is that? Okay, yeah. I tend to use Blitz 3, Amiga Blitz 3 as much as possible. It's a much nicer environment to use. But for whatever reason, like, I know people say that it crashes quite a lot, and I haven't really noticed that. It's always worked really well for me, except when I started streaming. It started just falling over every time, like. Wider settings. Shape. Can't remember what that's supposed to be, but let's go with 300. So that was our two-player Tron game. You see, And that's basically the culmination of that tutorial. Got a little bit of parallax, a little bit of collision detection. You know, it's got some sprites involved. You know, it's got 2-player split screen thing. It's simple enough stuff. It's AGA, not really, you know, not exactly pushing it with my limited artistic skills and blatantly ripped off things. But yeah, it's just 2 cop lists, but it's the same bitmap. You see, and so that's how it works. It's very, very simple. And then this press fire thing and the hearts, the lives, they're sprites. And that's it. Now, because there's no AI in it, it's only 2 human players. So it's kind of tricky to play against myself because they'll just run into each other very quickly and the game will be over. But it also supports firing the disc. So it supports 2 fire buttons. So 1 fire button for speeding up and the 2nd fire button for shooting. And yeah, and a nice pixely crash animation. But yeah, that's it. So I can go through that kind. Well, that's what happens when you use the mouse. And yeah, just use the sprites for those things. Let's see, how do I quit this? Oh, yeah, there we go. But yeah, so that is that works quite well. And yeah, that was the example that was printed in Amiga Future. Like, that was the end of the tutorial. So that was kind of what it was all working up towards. Now, from the simple little snippets that I've been working on so far, it's quite a big jump to go to what's here. But ultimately, it's not that bad. The code is fairly simple. It's just a lot of snippets that you've seen before, you know. So it uses buffer Blitz, and it uses it uses the standard sound library, and it uses a channel for each bike. Yeah. Well, yeah. So I can probably spend a stream going through this code. Yeah. No. As I'm sure you saw the other day, it's not. it's not the most the most wonderful viewing when I'm sitting there, you know, like, why isn't this working? Why isn't this working? That's private time. But yeah, this is basically doing yeah. But yeah, it's kind of yeah, I end up doing a lot of silly things and be like, I spent half an hour trying to fix a bug that I've just introduced myself, doing something stupid. So yeah, I might cover some of the stuff, but I don't know, because I'm not even sure what my entry is going to look like. You know, I have a bit of an idea, but yeah. Well, actually, you know what? I've just remembered. I have a much simpler game. Was it Amiga Ireland? Oh no, that's different. That's F-Tron. What was it called? I did a thing at Amiga Ireland where it was basically a Pong game, which is a lot simpler, obviously. And I could probably run through the code on that now, if I can find it. Amiga Ireland. Oh, Well, we'll see how it goes, you know. I have to see the Scottish Amiga group are doing sort of a team effort, because you know my programmer art is programmer art, and but a couple of the guys seem to be pretty decent at pixel art. So so I think I'll do the bulk of the coding. Some of the guys can do the coding as well, and hopefully between us we'll get something that looks reasonable. And you know, I have to find someone who can do sound. Actually, one of the guys can do music actually, but yeah, we'll see how it goes. But I think how the code looks at the start probably won't be pretty. Anyways, well, sure. Look, I can't remember where that bloody Amiga Ireland tutorial was. It's not in here. There are articles. No. Where did I put it? Possibly on a different machine. Oh, actually. Well, here, let's have a look at another game, like, what's a simple game that I've done? Well, Dodgy Rocks isn't a simple game. But, oh, excuse me. I did a version of Atoms, and I did a sort of a tic-tac-toe thing. They're not, oh, Mercury the Robot, that's a simple enough game. Yeah, I don't have anything that's kind of particularly simple, or any simpler than the Tron game, really, to go through. But, you know, we can go through that. But a couple of things, that I'll show you. First off, because you don't have string constants in Blitz, but you can just assign something to a variable. It's kind of basically will do the same thing. And this here is a particular string that if you insert this string into the executable, it will show up with the, you know, the Amiga DOS version command. So when you compile the file to its final executable format, you can use the version command to get this detail, or you can use, you know, the right click, you know, if it's Amiga OS 3.9 or you've got a fancy file info window, you can use that to get the version information as well. But basically all we did was, these are the properties of each player. So lives, direction. So, and I'm putting comments in, like you see here, and this is what I'm saying, you should put comments in, because after writing this 4 years ago, I wouldn't have remembered any of this, and I'd have to troll through the code to try and figure it all out. So direction, speed, so the number of pixels moved, previous speed, X and Y, previous position, X and Y, previous X and Y, because it's double buffered, you kind of need to keep track of a couple of things in a go. And because it's drawing the line behind it, that's the color of the line that it draws. Crash is a counter, and that's basically the delay between when you crash and when the game starts again. Is, you know, it starts this counter, and that for a start will do the animation frames for the crash, but it also kind of introduces the delay, so it doesn't like immediately go back, reset itself. Anim frame is yeah, the particular frame of the animation, because if you look at the bikes, they have a sort of a motion kind of animation on the tires, but also for the directions are all sort of separate frames. Sound frame, I can't remember what that's for. but I think it's to do with the engine sound. There you go, because I didn't comment it. Let's find out what that's used for. Oh yeah, so I'm not even checking the register there to see if the sound is playing. All it's doing is I basically wait for a certain number of frames to pass, and then I restart the sound. And it's as simple as that. We can see here that basically I'm changing the speed of the changing the speed based on the joystick button. Now, because we want to use 2-button stuff, we can't say if JB equal to 1, which is what happens if you press the single button or the left button or the button number 1. Okay, we have to AND it with 1 because if the player is pressing 1 and 2, you get the value of 3 because they're 2 separate bits, bit 0 and bit 1. So you want to make sure you're only checking the first bit, because if you're saying if JB equals 1, then it won't register the speed up if they have both buttons pressed. And so that's kind of, it's important to do an AND there for that. And basically all we have here is just a big kind of load of game logic that calculates whether, if things are moving to deal with them. Has the disc already been thrown? If the disc hasn't been thrown, then we'll let it be thrown because if the button fires. And the disc gets its own direction, which is initially, obviously it'll go in a straight line, even if the player turns. And and then we get a sound on, and channel 1 minus I basically is a way of choosing which channel. So basically the 4 channels are set up so that each player has 2 channels, like one for a projectile, one for projectiles, explosions, etc., one for the engine. And so basically, that's how I kind of calculate it, because this is all in a big loop where I is the player's dealing with 0 or 1. So it'll be channel 1 or channel 0 for the sound that the disc makes. And you see here that we draw a line from the position 2 frames ago to the position the last frame, and that's how we leave the trail behind the bike, and we do it in the pen of that particular player, and then we do the line again to the current position. So because what was happening was, if it has to be 2 frames ago because it's double buffered, you see. So the last point might be 2 frames ago, and if you turn in that time, you get weird graphical glitches and stuff like that. So it draws it to the previous one, and then to the current one again. And this is our scrolling viewpoint. So the view x is basically the coordinates of the bitmap that we're looking at, and it's x minus 160 because of course it's a 320 pixel wide screen. So we want the player to be halfway across, but if the view is less than 0, then it's equal to 0, and if it's greater than 319, so we limit it to these positions so that we don't move past the end of the bitmap, because the bitmap is 640 by 512, I think, or 640 by 400 or something. And that's basically it. So that's how we get our scroll to move until it hits the end of the bitmap, and then the player moves. Yeah. So that's it, and it's the kind of thing. It's the kind of thing that gets you funny effects if you don't do that. Like, you know, if you kind of think, oh well, it's facing the same direction as the player, but you get things like, you know, there are certain, I can't remember the name of a shooter, but there was one shooter, and it was like, you know, you're firing up the screen, and if you move to the right, the bullets move to the right as well. And it was yeah, you know, it's happened. You know, it does happen. But the way around that's basically to spawn. Yeah, it could be an interesting mechanic if it's, you know, in some cases, but but yeah, basically you have to spawn off a new object, copying it. Hey, Zuperdan, welcome along. What I have here, sorry, you know, snack time and all that. What I have here is the code that I finished the Amiga Future tutorial series with, and it's a basic Tron game, and it's quite a bit of code. It's quite a bit of code. It's 800 lines of code. It's a simple Tron game. It's but it uses all the techniques that are through all the tutorials so far. So basically, you know, there's nothing really in it that we haven't seen already, but there's a lot of it in there. Hey, well, good stuff. But thanks for popping in anyway. But yeah, so this is yeah, this is Tron. So I was just going through a little bit of this code to see what we're you know, what's you know, anything of note to point out. So basically, we're loading our sprite sheet. We load the palettes separately, and because I used the you know, the basically because I used the magenta background for when I was doing up the assets. I didn't upload any of these code snippets or examples yet. I will. I'm not sure about whole programs like this. That might be a bit. I don't know what stories. Like, I think they should be fine, because they print it. You know, these articles are now available for free to download, but they're in image form, so you can't like copy and paste the code. But the code is there. If you can just like copy it and copy it across. I do have a GitHub. I will put the stuff on there at some point, and post the links in the various places. There is nothing on the GitHub of note, because I think there's bits on it, but I don't have anything public, basically. But yes, I will post these code snippets on GitHub, and yeah. Well, like I said, I've got nothing public on it, so fair enough. I will see if I can remember my login details. Yeah. Yeah, it's fairly obvious, as it turns out. But yeah. Probably could have guessed it. Cool. Yeah, I think maybe at some point, like, I could have guessed it as well. Maybe at some point during the week I'll upload all the snippets that I've done, and be able to yeah, so, and I'll post the links in all the usual places on the Discord and in the forums and stuff, so that yeah, so that you can download those bits of code that I just that I've gone through. Yeah, because yeah, no, it's like I'm just flying through the stuff here, but if you don't actually have the code in front of you, it's a bit of a pain to stop the video and, you know, type in stuff, and then, like, yeah, it's just messy. But was there anything else that and actually Zuperdan, do you think you have a better place to put these snippets and stuff like that? You know, because I have a like I can just set up a project on GitHub and stick them all in there, but it might be yeah, like that might be enough. That's fine, but I can also send them to you if you want to have a more dedicated space for them. I don't know. Yeah, I have my own web space that I can throw them on as well. That's like yeah, that's basically it. Yeah, I'll just do it everywhere. Fine, no problem. I will do that. And yeah, that'll be no problem at all. I'll post the links when I do. But yeah, oh no, yeah, there was something. Zuperdan, you asked about interrupts. I'm Irish. I'm not in Ireland. I am in Glasgow, actually. I moved to Glasgow a few years ago, but I'm Irish, from Wicklow. Yeah, there you go. Yeah, so that's my Amiga Ireland T-shirt, because I've been to every one of them. Yeah, so oh, you're Newcastle, Ireland, or Newcastle, UK? Okay, yeah, fair enough. There's a Newcastle in Wicklow, much smaller and not many stag parties. But yeah. Anyways, there you go. I'm sure there's a Newcastle in kind of pretty much anywhere you look. There'll be a Newcastle of some size. Yeah. See, the thing is with interrupts, it's kind of oh, they're basically going to be anywhere where there was a Newcastle at one point. I think, you know, or someone from Newcastle moved there, which is probably more likely the case in Australia. But yeah, in Ireland there's like loads of villages and towns called Newcastle, and it's basically because there was a Newcastle built there at some point in the past. But yeah, so interrupts. For, you know, let's start at the start. So basically, what an interrupt is it's almost like a function that gets called when a particular hardware event happens. Well, or a software event, but usually it's a hardware event. So the v blank is the obvious one, I suppose, and that is a yes. Yeah, there are. So basically you have well, yeah. So you've got 7 hardware interrupts, and then you can have software interrupts as well. But I'm not going to go into that because I don't think Blitz supports them. So it's more like use semaphores or something like that. Use flags if you want to do that kind of thing. But yeah, interrupts basically, yeah. Whenever a hardware event occurs, your code is suspended, and everything's suspended, and the code that's associated with that interrupt is jumped to straight away and gets absolute priority over everything else, except other interrupts. So you've got interrupt levels, and so you've got, I think, 3 interrupt levels, and No, 7. Sorry, the 7. There are 7 interrupt levels, and there's hardware generally associated with each. 7 isn't actually connected to anything on the Amiga, but it's used for like the freeze cartridges and things like that. Yeah, that's it. Yeah, so so like if you have an action replay and stuff like that, so that's called a non-maskable interrupt. So that there's nothing you can do. That interrupt is going to happen if you press the button, but there's nothing physically on the Amiga that actually uses that. But it's a function of the CPU, so it works and it's there. So you've got interrupt 5 is the vertical blank, and that triggers every time the screen draw, the old CRT kind of, that's how the graphics are drawn anyway, regardless of what screen you have. It goes, top left, across all the way down to the bottom right, and then you get this vertical blank, and you can have an interrupt fire when that happens, and then your normal code stops, the interrupt code runs, and then your normal code resumes. So in Blitz you use setInt and endSetInt to do that, so you define an interrupt like that. But the CIAs, you can use the CIAs to trigger interrupts basically on a couple of other things, and they're interrupts 2 and 6, and they can be, there are other things that use those interrupts as well, so this is where it gets a bit but so basically your code runs, and what you have to do is, if you have an interrupt, is you have to kind of first of all make sure the interrupt is actually for you, and you do that in code basically by, if you want to control the hardware, you do that to see if it's the actual event you're looking for, because multiple things can use interrupts. Like for example, interrupt 6 is it's one of the CIAs, I can't remember which one, but it's also used for the clock port interrupt. So if you set an int 6, and if you're like, let's say, writing software for dealing with the clock port, you have to make sure that it wasn't the CIA that triggered that, and it was actually your hardware that triggered that. So you query your clock port hardware, and it will usually have some sort of flag that says, yes, that was me, and then you run your code, and you ignore it if it wasn't your own hardware. So you do have to be careful with shared interrupts like that. But yeah, so you do an interrupt in Blitz using like setting 5, and that's your interrupt set. So you put your code in there, and that any code that's in there will execute whenever the vertical blank interrupt triggers. Now you do have to be careful because you do have to be careful with that, especially because interrupts should be as fast as you can possibly make them. They really need to be quick, because like if your interrupt takes more than one frame, you are going to absolutely cripple the machine. That's it. It's because basically because the interrupts never stop firing. No, it doesn't override interrupts. Interrupts, you can have multiple interrupt handlers, and what'll happen is they'll all run one after another, or sort of, I don't know if they run in parallel, if it does it that granularly to that level. But if another bit of software has an interrupt installed, that will also run. So you have to bear that in mind. So if you do have too many things running stuff in the vertical blank interrupt, you will run out of time in there. So you need to keep it as quick as possible. But so if you had so the CIA ones are int 2 and int 6, and they're triggered by a couple of things. One of them is the timers. You can set a timer to trigger an interrupt when it rolls over. But there are other commands that use the timer, and in a sort of a... Actually, now AmiBlitz has nice includes for using the timers. I don't think Blitz Basic 2 has an equivalent. Let's see. Blitzlibs. So the deflibs are the third-party libraries. Is there a... Let's see. Is there a CIA lib? I'm sure there is a CIA lib. Well, yes, that's true. Actually, yeah. If you've disabled the OS, then yeah, you've disabled the OS. And if you're in Blitz mode, your OS is disabled. So that's yes, that's a good point. Yeah. So if you Prince Phase, I'm not sure how familiar you are with Blitz Basic, but Blitz has like Amiga mode, which is system friendly, and Blitz mode, which is shut down the OS. And that essentially does a kind of a, you take over the whole machine that way. And you need to be in Blitz mode to use things like sprites and a lot of the more powerful graphics commands and libraries. So so you are grand. So if you're in Blitz mode, all the interrupts are yours basically. And that's why, for example, the floppy drive stops ticking when you're in Blitz mode, and you know all that stuff. You know that happens. Yeah, Q Amiga is nice because that lets you keep this display intact, and you know it's good for loading assets and stuff. So what I use that for is loading or saving games or loading assets, so I can put up a loading screen and just sort of like a please wait or whatever screen, and then go into Q Amiga and do what I need to do. I'm pretty sure there was a CIA library, but I don't think I've ever used it. CIA tracker lib. What's the hardware lib? Not really, but basically, yeah. There you go. I have not used that CIA tracker library, to be honest. But I'm interested to see what it can do. CIA tracker lib. Oh, okay. Of course, the document's missing. Brilliant. But yeah, so you can set up an interrupt to fire on anything. If you're using, you've got timers on CIA-A and CIA-B, so they have one of them's 2, one of them's 6. Can't remember which is which. Let me see. Sorry, I will have a look at my schematics here. And come on. The interrupts will fire when the timer is set to fire them. You see, so the CIA interrupts are they're quite flexible. Let me see. Okay, so just because it was annoying me, interrupt 6 is the even CIA, and interrupt 2 is the odd CIA. And basically, you'll see it in the hardware reference manual. There's a bit on using the CIA's timers. In the there's a separate chapter for them. And so you've got so basically so you can do it for, you can set it so one could use CA to scroll. Well, you could. I mean, you'd have to be careful with your synchronization, because if it wanders out of sync for whatever reason, you just want to make sure that doesn't happen. You need it to be in sync, and so you could use it for timing that, because it does run on the horizontal clocks, or one of the CIAs uses horizontal clock as the time of day, but they both run off the 700 kilohertz clock. So they both should be able to do a reasonable enough resolution for if you wanted to position something on the screen. But there are better ways of doing it. Use a copper with use the copper to trigger something at a certain point. Something like that is far better, I would have thought. But yeah, basically you can trigger an interrupt with, yeah, use it for animation purposes. Absolutely, yeah. I would have thought just having a counter in the main game loop would be simpler, but yeah, I don't see why not. So you've got 2 timers on each CIA, so you've got 4 timers in total, and they can all trigger an interrupt. What you need to do if it triggers when you trigger an interrupt is when you receive an interrupt, like I was saying before, you have to check with the CIA whether it was actually what you thought it was, because the interrupts will also be triggered for the serial port. Yeah, if it basically, yeah, if you know, and this is the thing that's happening with some games, is that you know, when you use WHD load and you've got something plugged into the serial port and this random byte arrives at the serial port, game craps out because it this interrupt is fired and it doesn't have anything to do. It doesn't have any kind of relationship with it. But yeah, exactly. Yeah. So there is a register. There is a register on the CIAs that can tell you whether an interrupt has been triggered. But basically, yeah, when the timers reach a certain point, so the timers wrap around, okay? So every time they hit 0, the timers are basically just counters, and they count at whatever frequency they're running at. But they wrap around, and then every time they wrap around, you get an interrupt. And so you can set those timers to whatever value, so they you know, so it's consistent, or you know, you can set them to fire once, and then once they hit 0, they stay there, and so you get an interrupt then. But you know, they're actually quite cool. They're nice devices. But yes, you need to read the there's an interrupt register. Sorry, I have to look it up and see what it's called. But basically, any hardware that generates an interrupt you'll be able to have some mechanism for identifying whether it called the interrupt or not. So yeah, the interrupt control register. So there's one of them in each CIA. So you know, so you use int2 or int6. You and then you check your interrupt control register, and then well, that's yeah. Now this is the thing. I don't think there's a particular benefit really. If your loop is already running, like, you know, synchronized with your frames, then you know you've probably got timing there anyway. I wouldn't say there's a massive difference. No, you know, it's probably slightly, but I can't see it being a big difference. And you've got overheads when an interrupt triggers. You've got overheads because you have to clear the stack, and you have to, you know, there's a context change there. So I don't know whether it's worth the minor benefit there. But let me see. But there's a. Let me see. There is a general interrupt control register for the Amiga. Like that's what Prince Phase is on about there. So that is. But that basically that's like an overall interrupt. Like, so that tells you, and that controls whether, you know, interrupt 2 or interrupt 6 is available, or, you know, that's that end of things. But if it doesn't tell you what caused the interrupt, and that's what the interrupt control register on the CIA does, and other hardware, like if you've got a clock port device that triggers an interrupt, it will have a register as well that you can read, or something like that, you know. Yes, exactly. So the CIAs have a register, and it has a different bits. It's a bit flag, and it'll tell you whether it's a serial port or a timer interrupt. And so that's what you would do from a hardware perspective, or from a code perspective. You would you'd check that to make sure that's what it was. You see, but in Blitz, yeah, you don't have to. Oh, well, that's it. So in Blitz, that is how you would set that up. For example, you have to. That would assume you're going to be dealing with the CIA timers directly, and that is doable. You know, the hardware reference manual includes all that information, so it's perfectly doable. And the hardware wise, it's actually kind of like those CIAs. You kind of get that kind of. It's not that different to what you get in a modern microcontroller chip. Usually has a couple of interfaces like that as well, including timers and stuff like that, and they all work pretty much the same way. They're quite cool. You get your interrupt, check your flags, and and do what you need to do or not, depending on what it was. But yes, if you were using it to time an animation or something like that, I don't think I'd even be bothered doing an interrupt. You know that I would just read the CIA value as it was and see, if it's expired, and then reset it if it has, and increment my counter. So and that will give you timer like an animation increment independent of your frame rate. So if you've got a variable frame rate in your game because more things are happening or whatever, that would give you sort of a threaded. Oh, I see what you're saying. Well, yeah. I mean, you could, like, if you have full control of the machine, you could do that. It wouldn't be multitasking. Wouldn't thank you for it. But yeah, like, why not? Basically, you need, for it to trigger again, you need to reset the flag. But yes, yeah, you could. Yeah, absolutely. Yeah, there you go. I don't really know what else to say about it. Really, it's yeah. I would never have thought of using it as a sort of as a multi-threaded thing, because it's not really multi-threaded anyway. Yeah. But yeah, you could if you want the copper to do it, and so you have an interrupt fire at a certain point on the display, fair enough. I would have thought they're just, yeah, they are, yeah. Yeah, well, yeah. This is the thing. If you're a modern coder and everything's very, very, very modular like that, and you've got lots of threads all over the place, and yeah, it's a different paradigm altogether. This is it's as retro basics goes. This is pretty decent, but it is a long way behind modern languages. Yeah, exactly. It's like I wouldn't. What I would do is, I would have a sort of a state machine going instead, and I'd have a couple of different, counters. And if I want some code to run every X frames, I would have that in my main loop, and do my multi-threading that way. But yeah, you could. Blitz 3 does come with a decent include that has nice wrappers for the timers. But yeah. So let me see. Maybe blank, I think. What was the other one? E-clock. Oh, damn it. clock. Now, so this is a nice include. That gives you basically, you know, basically a lot of timer functions, and you know, they're not interrupt driven. But basically you check. You know, you know, in your game you'd be check if the time has passed, and if it has, then you do your thing, and it's quite good because it's you know, it's you know, it's a nice yeah, it's you know, it's a nice system to use, and because it's all multitasking friendly and stuff like that. Yeah. Yeah, I think it's far beyond scope for your average game, I'd say. You know, yeah, it's a different story if you're looking to multi-thread, you know, an interface or something like that. Mind you, it's like you know, I'm saying this is all kind of primitive the way Blitz works compared to a modern language, but you know, I still think, you know, the Amiga's way of doing a GUI is nice. You know, it's all multi-threaded. It's a separate task for the, you know, for the actual buttons you click, and it's like, I wish other platforms did that. You know, you're not, you know, writing code for Windows, for example, and you kind of lock everything else out because your program's doing something and it can't respond to the button, so the button doesn't even move, and it's like, yeah, oh well. It's different worlds. But yeah, so this, you can see here that this has some nice little yeah, yeah, like the vertical blank is a common one, obviously, and a lot of people use it. Yeah, absolutely. I could talk about that all day. But yeah, the vertical, like a lot of games use the vertical blank for reading the controller and things like that. Especially if you've got an analog controller, or you know, something like that, because that needs to be triggered. You know, it needs to be triggered at a certain point in the frame and then read at another point in the frame. And so, you know, to get consistent timing with that, you kind of want to do that using interrupts rather than using it in your game loop, where, you know, the timing will change based on how much you have to blit. So you have to, yeah, so you have to keep the timing more consistent. But yeah, it's yeah, it is, the vertical blank is a useful one. Yeah, like I say, for flipping, I tend not to use it for graphics stuff much either, because I double buffer in the main loop, and I don't need to, I don't bother swapping over. So if we look at AFTron here, where's my this is all getting stuff prepped, all my functions, reset game, and then yeah, I just basically double buffer with that. So current bitmap just gets swapped around. But that's, you know, that's all it is, because it's all synchronized to the display with VWait. You don't need to do it in an interrupt. So, you know, that's basically, you know, that does it for you. Let's run this again just for the laugh. So, saying there, Zuperdan, this is the culmination of what we were doing in the tutorials. You've got a dual playfield, parallax scrolling, and sprites and blitting, all buffered blitz, all in the one thing, and 2-button joystick control, and yeah, that's it. But yeah, the press fire stuff, it's a good use of sprites is for overlays and things. So you see the lives, the 4 hearts there, and the press fire, they're sprites. That's a nice way of getting that kind of stuff, especially in a scrolling game where the graphics underneath are going to be moving. So yeah, that's like I was saying earlier, it's a 2-player, so that when you have the mouse set up, it doesn't play well. Yeah. I see. Yeah. Yeah. Yes, indeed. So you've got other things running while the game is doing other stuff. Yeah. No, that's fair. That's a good reason as well. Yeah, that works. Well, yeah. So any, I think that's it. I don't think interrupts are going to play a big part in games as such, and it is as Prince Phase is doing. It's a big subject. Yeah, you could, I'm sure there are books written on interrupts, but yeah, it's a very nice thing. It's kind of fundamental to how so many computers work, and it's like it's kind of one of the fundamental building blocks of a system. But yeah, it's that's it. So, cheers. Yeah, not sure if it did, but thanks. hopefully it made sense. Okay, so I don't think there's really a lot else for me to talk about here. So if you have any questions, fire away. Otherwise, I'll probably wrap it up soon enough because, like I said, I'm still hungover and I need to go to bed. Rock and roll Saturday night, Oh dear. So there you go. Yes, I will upload. I'll try and upload all those clips of stuff before or next week, or sometime this week. And in the meantime, I'm going to do a stream on the PHX audio library and setting that up with Blitz 2 and all that kind of stuff. So that should be. Try to do a Pong game live. Yeah. See. Yeah, I did do a bit of the. I did do the Pong game at Amiga Ireland, but I was kind of like I already had it done. Yeah, we'll have to see about that live coding. Just yeah. We'll see. But yes, it is not a bad idea. So do the Pro Tracker library and the Pro Tracker sound library. Yes, have it off screen. And I'm like, I swear I'm writing this on the fly. But yeah, I'll find it and I will. I'll find it and I will even throw it up on, as a code snippets for helping with this. But yeah, so I'll do that and then I will. Yeah, I think that'll kind of be it for like I said, just it for getting people started on Blitz Basic for the competition anyway. And no, that's not a bad idea actually. Go through the Pong one on the fly from scratch, or semi on the fly. Yeah, I might do that. So I'll do the library. What else was there? More debugger stuff. Like there's more debugger stuff I suppose I could do. There's a lot to it, and I touched on it there way back in like the first or the second one. So there is more I can do on the debugger, and I'd probably maybe do that along with the Pro Tracker library. And what else is there? I know Zuperdan's been paying a lot of attention, so he might have the good suggestions. But yeah, I'll have a look at that. Yeah, the library numbering is a pain in the hoop, to be honest. So what you have is, yeah, and that's part of the reason I use Blitz is because, I can do all this stuff in C if I want, but you get. I was gonna say, I wouldn't be able to do it in assembly because my assembly is pretty rudimentary. But you can, it's nice. It's very quick for doing some things, and some things you don't need anything more than that. And it's kind of it's a nice level of being able to do all that stuff, but with a sort of a slightly higher level. And yeah, that's why I like Blitz. So yeah, ProTracker Lib, the library numbers. So you've got like a total of 255 slots, and each library has to have a unique number. And so the problem is that over the years, different people have added loads of different libraries, and some of them have clashing numbers. So, you know, so what you end up with, like, you know, you have to choose between one and the other. Now you can change a library number. There's a tool for that comes with Blitz, and then you can rebuild your library, your def libs, to include all the, you know, all the libraries, and that's fine. But when you do that, if you swap the Blitz Basic 2 code, you know, basically the Blitz Basic 2 source code format is tokenized. So it stores every command as a byte for the library and a byte for the command. So it's a, you know, it's a byte.byte kind of format. And if you've used a different number to someone else, you can't share that code with them, because it'll come up either garbage or unrecognized token. So you can't do that, but you can share the ASCII, of course. If you can save it as raw text, then that's the way to do it. AmiBlitz 3 doesn't have that problem because it saves in plain text anyway. Yes, you can import plain text as well, but you just have to remember to do that. But AmiBlitz 3 got rid of the tokenized mode is still there, but by default it saves as plain text and loads as plain text, so it works a lot better. Yeah, absolutely. So if you want, I will do that in the next one. I think, yeah, I think, well, yeah, do installing libraries, installing Blitz itself, installing AmiBlitz, and using the debugger. I think that's all that's a good set of topics for the next stream, I think. And then we can look at the ProTracker Lib, maybe a different one, because that's quite a big one as well. Like I said, because it's different versions knocking around, some of them have different commands. But yeah, that's it. So yeah, what I'll do is I will create a sort of a blank virtual hard drive and install from scratch live and just see how it goes. I normally, my schedule's a bit hit and miss, you see. Like, I haven't been streaming for the last week because my in-laws were staying in this room. But yeah, I normally stream on a Tuesday, sometimes on a Friday, but it changes. Sometimes it's on a Wednesday instead of the Tuesday. It's kind of, a couple of times I do it on a Saturday. It's just kind of, it's more when it works. But yeah, that's it. So that's why I do have them saved. Like, I do save all the recordings, the VODs, and upload them to YouTube as well. So they're all there. Because people can come back to them and can fast forward over all the shite talking that I do, you know. Aha. Yeah, I've yeah, oh, there you go. So there's an awful clash there, but I see. Yeah, that's kind of it. Thank you, Spike. It's quite simple and very effective, isn't it? And it works very well. But yeah, that is it, I think. Yeah, so I'll do all that stuff the next one, setting up Blitz and all that kind of crack, and that can be the next one, because that is going to be, when will I do it now? Let me see what date it is. Tuesday will be the 31st, so that'll be the last day before the the 31st will be the last day before the jam starts, so that's a good yeah. Yeah, so that'll be a good time to do the full setting up and stuff like that. Yeah, cheers, Prince Faze, I appreciate that. And yeah, that's it, because I know a lot of people, like, there are a couple of times I just stream when I can, and it's like, you know, I have a massive list of things to be working on myself, and things to fix, and things to do, and things to watch. So it's not a very regular slot, but you know, I have done streams of games and stuff as well, and more often than not it's on a Tuesday, but sometimes one of the weekend days as well. But yeah, I'll yeah. Yeah, so I say on Tuesday maybe I'll do the stream on setting up the environment, all that kind of stuff, the debugger, and get everything set up then so everyone's be ready to go then first thing on Wednesday. Excellent. That's well, that was kind of what kicked off the idea for me. Kind of like, oh, that's a nice idea. I'll do that. I'm sure if for anyone looking, that's the details on the jam there. Go and join it and make a game, and you know, enter, and it'll be good crack to see what people come up with. And yeah, it doesn't have to be an elaborate game. It doesn't have to be extremely complicated. A lot of the best games aren't. You know, and you know, code or artwork is I'm sure going to happen as well. Nothing wrong with that. You know, so yeah, it's all good. That is Zuperdan is the host of this jam. So I'm going to enter, hopefully, with what little time I have, myself and a couple of the Scottish guys. And yeah, so we'll give it a go anyway. We have a couple of ideas. And yeah, there you go. Okay, so what I'm going to do is I will... oh, hey, Terrible Fire. Have you just joined in? Yeah, that is the thing. Feature creep and scope creep and all that kind of stuff. It's bad. It's bad, and it will happen. I know it'll happen for me. But yeah, I was just wrapping things up. I was saying that we're the Scottish guys have some ideas for the game, all very vague ideas, and a couple of pixel drawn sketches of things. But that's about it. So we'll see how it goes. But yes, I'll be starting on that next week, and yeah, yeah. Well, yeah, that's it. You just have to take each little bit at a time, and go with, you know, do what you can. Right. Yes. Sorry, Terrible Fire. I know you've just arrived. I am going to go to bed because I'm still hungover. And yes, I'm going to go to bed. So I'm going to go raiding someone. Who's going? Yeah, careful now. Ravenous Devils. Ravenous Devils. What is that? That's a new game, I think. From what I know. Oh, zombies. Anyone want to watch someone play zombie games? Yeah, no problem. It's a pleasure, and thanks for coming along for the chats. And yeah, so I think what we're going to do is we are going to raid Tins93, who she doesn't do retro stuff. She does good streaming, and she recently just got 1,000 viewers and did a 24-hour stream, and she was in bits. it was quite impressive. But yeah, okay, so I think we'll raid her. Now, where's my raidy thing gone? Raid. Raid. Oh, I'm falling asleep here. Okay, but yeah, no, thanks very much, guys. And let us do... Oh, no, where is it? Come on. I've lost my windows here. Damn it. Okay, here we go. Okay, let's go. Right. And yeah, good night, and take care, guys. I'll talk to you again on Tuesday, and yeah, think up some questions. Okay, thanks very much. Good night.
Thank you so much for the raid. Playing some retro. What retro games are you playing? Hey there, Super Dan. How's it going? Welcome, welcome on in, Raiders. Retro coding. Coding? I've never heard of Blitz Basic before. Can't say I have. How are you, Friar? It's the best kind of retro. Oh, okay. Ah, game making stuff. So making your own game? I would be intrigued to see that. It's older than me. That's probably why I've never heard of it. More than likely why I've never heard of it. First Gravedigger and now this, I'm starting to worry. Don't worry, Junkie, don't worry about me. Probably older than my mum too.